Good morning to one and all. I'm Dr. Sumitra, an associate professor from the Department of Computer Science and Engineering. And today's session we are going to discuss about rectified linear unit. The rectified linear unit is widely used in activation functions in deep learning. It is a simple yet powerful non-linear function that introduces a non-linearity to the neural network, enabling it to learn a complex pattern and the relationship in the data. The rectified linear units is defined by a mathematical equations of f of x is equal to maximum of 0, comma x, where x is the input to the function and rectified linear unit replaces the negative values of the input with the 0. While leaving a positive values unchanged, this piecewise linear activation functions has gained a popularity due to its simplicity and the computational efficiency and effectiveness in training a deep learning neural network. The graph for this rectified linear unit is given below. And here the unit is a piecewise linear function that is a 0 for all the negative inputs and has a slope of 1 for all the positive inputs. Mathematically, we can also have the representation in such a way. The graph of this rectified linear unit resembles a rample with the short turns at the origin of 0, comma 0. For a negative input, the functioning of in output 0 and for the positive input, the function outputs the input value itself. The simple thresholding operation makes a rectified linear unit computational efficient and suitable for training a deep neural network. And why this rectified linear unit is a good activation function is all about. It is very simplicity. The rectified linear unit is a simple activation function that allows a thresholding operation to set a negative values to 0. This simplicity makes a rectified linear unit easy to implement and the computational efficient, leading to the faster training for a deep neural network. And we have a non-linearity where it introduces a non-linearity to the neural network, allowing it to the learn complex pattern and the relationship in the data. The non-linear nature of a rectified linear unit enables a neural network and makes accurate prediction on various tasks such as classification, regression, and the image processing. Avoiding using a vanishing gradient problem. This helps a mitigated vanishing gradient problem which has occurring when gradient becomes extremely small during a backpropagation, hindering and training of a deep learning neural network. By allowing a gradient to the flow freely for a positive inputs, the rectified linear gradient enables more stable and efficient training, leading to the faster convergence and the better performance. We have a spare automation where it introduces sparsity in the network by setting a negative values to 0. This sparsity can help reduce overfitting by preventing a co-adaptation of neurons and promoting the learning of more diverse feature. Sparse activations can also be lead to more efficient memory usage and faster interference in neural network. The fast coverage where it remains active for a positive input, allowing the network to learn quickly and convergence faster during training. This piecewise linear nature of a rectified linear unit ensures that gradients are not zero for a positive input, facilitating efficient learning and faster convergence towards optimal solution. The major advantage of this rectified linear unit is simplicity, where it's simple to implement and computational efficient, making it suitable for training a large scale neural network, and nonlinearity, where it introduces a nonlinearity to the neural network, enabling it to learn a complex pattern and relationship in the data. Avoid a vanishing gradient. It helps mitigate vanishing gradient problem by allowing a gradient to flow freely for a positive input, leading to more stable and efficient training. The spare automation, where it introduces sparsity in the network, which can help reduces overfitting and promotes the learning of more diverse features. The fast convergence neurons remain active for a positive input, allowing the network to learn quickly and convergence faster during training. The disadvantages is where it has a dying problem and unbounded activations, and it is not suitable for the negative inputs. And finally, we can say that this rectified linear unit is a popular adaptation activation function in deep learning due to its simplicity, computational efficiency, and effectiveness in learning a deep neural network. Thank you.